Welcome to the Go Design Patterns demo. Today I am going to show you few of the design patterns using Go language. The first pattern is Singleton design pattern. Singleton is a creational design pattern. It ensures that class have one instance. So in this scenario, this is a classic implementation of Singleton pattern. In this scenario, multiple Go routines could evaluate first check over here, and they would all create an instance of a singleton type and override each other. You can see over here in the test class, I have created two instances, I1 and I2. And since I1 is not null, the second time when the request goes or call to this get instance method is going to return the same instance, and that is why we will get output as instance of I1 and I2 are equal. I am going to show you quick demonstration. So this is classic implementation of singleton. We can see the output as instance of I1 and I2 are equal. This approach has a problem of overriding, so there is one more approach which is better than classic implementation. That approach uses a locking. This solves a thread safety issue, but it creates another potential problem. So there is no use of putting only locks in the method. Uh, Thus, this problem solves only the approach of thread safety. So I can show you the quick demonstration of this. You can see that this uses a lock over here and defers execution until the surrounding process returns. So we can see that instances are created in the same way as a classic, but using a locks. Again, this problem introduces a threading contention. So we have one more implementation of singleton, that is a singleton thread safe, in which we have an excellent standard library called sync. We can find the type once, and this will resolve a thread safety issue. So in this case, we will get only single incidence. This object will perform an action exactly once and no more. So we can see the execution over here. So this is a singleton implementation. This is a thread safe, as we are using a sync function over here. And I'm going to move on to the next design pattern, that is adapter pattern. Adapter is a structural design pattern, and adapter pattern uses this target interface and the adaptive parent structure, which implements the target interface, and client uses this target interface to create objects. So if you can see over here in the test, we are creating a adapter object using adaptive parent, and we are going to call a say hello method. So when we call a say hello method, we will get a implementation of say hello says that it will call a parent print message method, and which will print us a message. So we can see the execution of the adapter pattern. So we are getting a hello message over here. uh, there are two types of adapter pattern. One is class adapter, another is object adapter. So we have just seen the class adapter. The only difference between object adapter and class adapter is this will use two different interfaces. One is a target, as we have seen in the class adapter, and another one is a adaptive interface, which has a class which implements this interface. And in the test client, we can see that we are going to create a target object now, and that object is calling a say hello method of the target object class, which is implementing the target interface. And then that target interface, in the say hello method, we are going to call a print message method, which is going to give us a output as a hello. We can see the quick demonstration of this. So this is my object adapter pattern and it uses the target interface. So here you can see the output. Next I am going to explain chain of responsibility design pattern. Chain of responsibility is a behavioral design pattern which decouples sender of a request to its receivers by giving more than one object a chance to handle the request. So there is an interface called handler and there are classes which implements this handler interface. These classes are concrete handler 1, concrete handler 2, concrete handler 3. So basically there are three different handlers which implementing this interface and which receives a request using the handle request method and sets the successor using the successor method declared in the handler interface. So in the test class we can see that we are creating objects of this concrete handler h1 h2 h3 and we are setting a successor for h1 and h2. So based on the request we are going to see the each class concrete class implementation is going to check if that request belongs to that class. If not, it is going to set a successor and print a message. So based on the responsibility, each class checks for its own responsibility, otherwise it sets the successor. We can see the quick demo of this. So as I mentioned earlier, we have a handler interface and three concrete handler objects, and I'm passing a different input for the each handle request. So these are the handle request R2, R3, R1 and Rx. So we can see that the message has been printed when first R1 got the request, and since the this does not belong to R1, R1 has just set its successor, then request goes to R2 and then finally it goes to R3. So in this way we can have a chain of responsibility design pattern for a behavior. Next, I am going to demonstrate the strategy design pattern. In this design pattern, we have an interface sorting strategy, and this interface is common to all supported algorithms. The concrete strategy class, the chain strategy class is actually going to implement this algorithm using this strategy interface. So we have three different algorithms for bubble sort, quick sort and merge sort, and this in the client we are going to give an input data set and the strategy we are going to apply on this input data set. So there are three different strategies, three different algorithms you can say in the this implementation. First one is bubble sort and then strategy. Here we are going to give a quick sort and then third strategy, that is merge sort. So basically all the times we are changing the strategy for the same kind of input. We can see the quick demonstration. So this is a strategy interface and the change strategy class which implements that, and in the client we are going to change the strategy with three different algorithms. So you can see the output that this input data set is sorted by using bubble sort, quick sort and merge sort. This is all about the Go design patterns. Thank you.